Today we're going to be working on another Amazon's interview question. This is Leetcode question number 69, square root of x. They are telling us not to use any function like this or this in order to achieve that. We have been given x is equal to 4, the square root, the rounded square root like would be equal to 2. In case of 8, the square root is going to be this. Since we round it down to the nearest integer, 2 is going to be returned. We're going to be using the binary search for that. We will have a base condition that okay, if the x is equal to 0, just return 0. 0 square root is going to be 0. We're going to have our left equals to 1 and a right to the maximum number we have. And while true, basically we're going to do is like we're going to say that calculate a mid point, and this is just finding an average between the first and the maximum one, but we want to make sure that we do that. Otherwise what's gonna happen is that it's gonna be overflow if you just do left plus right divided by 2. So in order to avoid that, we're calculating the middle point here. So if the middle is basically what we're gonna say that okay, midpoint is actually greater than x divided by mid, right? So we're gonna say that the uh, uh, we are on the higher side, that our middle which we just calculated, which is the average or the middle point between the left and the right, is too big, because when we divide our x divided by that, right, that is um, that number, the middle which we calculated is actually bigger than x divided by mid. So that would mean that our mid is very high. We're gonna say that make the right equals to mid minus 1. Otherwise, uh, otherwise we want to check two things. If the mid plus 1, like whatever you made calculate the mid, if that is greater than the x, uh, so we know that the mid, if we are here, is actually less than the x divided by mid. If we are in this else, we already know that our mid is greater than our mid is less than the x divided by mid. If that is the case, all we need to see is it, if we add 1 to it, to our mid, does it become the other way around? If that is the case, return that mid. That is our answer. Otherwise, we're gonna say that okay, we are too small, we need to become bigger than that, so left is gonna become equal to mid plus 1. So that should do it. Let's run it. I wanted to see one more thing. So that is fine. What happens if we keep our right to x? That also does that. So we do not have to keep our right equals to an integer dot max. All we need to do is keep the right equal to the x, because a square root of x cannot be equal to the, basically in case of 1, yes, it can be equal to the same thing, but I mean, it's the square root cannot be bigger than that. So if x is our number, square root of that cannot be bigger than x. So that's why our right, uh, keeping it as x is gonna be fine. Okay, let's take an example here. Let's take an example of 8 here, or let's start with the simple one. X is equal to 4, our left is equal to 1, our right is equal to 4 again. We calculated the mid, which is 5 divided by 2. It's gonna turn out to be 2, so the mid is gonna be equal to 5 divided by 2, which is gonna be equal to 2, as the mid is just an integer. So is that 2 greater than that x divided by 2? So the answer is no, it is not. But then when we're gonna enter this one, and we want to see if the mid plus 1, which is 3, is that greater than 4 divided by the mid plus 1, which is again 3. So this is gonna turn out to be 1, so 3 is greater than that, so we're gonna be returning mid, which is 2. So 2 is gonna be our answer. In terms of the complexity, we are not really using any extra space, and in terms of the time complexity, it is logarithmic. So the time complexity is going to be log of x, where x is that number with the input number. That's all I wanted to cover in this video. Thanks for watching.